What's up, gamers? It's been a while. You guys have been killing it this semester. You really haven't even needed my help that much. But the foundation exam is right around the corner, and I know a lot of you guys are going to be taking that. So I figured I'd use some of my extra free time to do some of these FE questions. And so I got this one for you guys here today. This one is from the last foundation exam, the one I took. Was one of my favorite questions on it. I thought this was actually a pretty cool one. I haven't seen, like, I've practiced a lot of the old tests, and I haven't seen a question. This was the first time I saw a question like this. So let's get down to what the question is. So demonstrate your understanding of recursion by rewriting the following recursive function, which operates on a binary tree as an iterative function. In doing so, you must abide by the following restrictions. Do not use break statements in your solution. Do not write any helper functions in your solution, and do not make any recursive calls in your solution. Okay, cool. So what is iteratively, in case you guys don't know or don't remember? It's pretty much just not recursively. That's the simplest way to put it. So we just need to write this function using loops and things like that. So I mean, in the beginning, I think the first step you guys should do is even break down, okay, what kind of function is this? This function is an int function, so it's gonna be returning an int. Okay, so regardless of what everything else in this function is doing, we know that it's gonna be returning an int. So we can declare an int. Say, all right, so int. I like to call it answer. Sometimes on the answer keys, he uses retval. I like to use answer. Int answer equals. It's like, okay, what should we use in this equal? It's like, okay, so let's look at what this recursive function is doing. So we see that it's doing multiplication. All the math that it's doing to the ints is some type of multiplication. So we're going to set it equal to 1. Usually people pick between 0 and 1. I prefer to pick 1 just because if you multiply 0 by any number, it's always going to end up being 0. So when you do 1, you can I feel like 1 is more flexible. Okay, so we have int answer equals 1. That's part 1. I think that's 1 point, right? And now we need to think, okay, let's break down recursion. What is recursion? Recursion is a function that runs and calls itself until a base case is met. So pretty much a function something that infinitely goes until a base case is met. And it's like we have one thing in C that does that. It's the while loop. So think about what a while loop is. A while loop pretty much is a loop that goes on forever until the base case in the middle is met. So we have while something, okay? So we know we're going to be using a while loop. Remember, when you don't know how long you want something to go, you use a while loop. And when you do know how long something you need something to go, you use a for loop. So we don't know how long our recursive function is going to go. Depending on what root we pass in, it could be variable length. So we're going to use the while loop. And it says, okay, what should our base case inside the while loop be? And I think that this should be the most basic case. Whenever you're doing recursion, pretty much every time the most basic case is always going to be if root equals null. If the root is null, it's going to just return 1, if that makes sense. So let's put this in this while loop. So a lot of people would make the mistake where they'll say while root does not equal null. The reason you don't want to do this is because we're not going to be, if we look at this function, in no way is it manipulating the tree. If we pass this in, then we would have to manipulate what the root is, if that makes sense. So actually what we're going to need to do is we're going to have a temporary pointer that points at root, and then we're going to pass that temporary pointer in. There's the node pointer temp equals root, right? So we have this right here. So we're pointing at root. Think about it. How I like to think about it is like if we look at the function, we can see that pretty much all it's doing, it's traversing our binary tree, and then it's multiplying our answer by something. At no point is root being set equal to anything else, or the children is being switched up at all. So we're gonna do. So if we're gonna just pass through the function, whenever we're passing through anything, if we're passing through a linked list, a binary tree, and we don't want to manipulate it, we always use a temporary pointer just to point at each indice. So we have while temp does not equal null, our function is going to run. So okay, and then actually we know that down here we're going to be returning answer no matter what it is, so we'll just do that. Okay, so pretty much it's going to say, okay, if temp is equal to null, then it's going to skip the while loop and it's going to return answer, which is 1. And if we look here, if root equals null, return 1. So awesome. We got the first base case down. Let's move on to the next base case. It says, okay, if root left equals null and root right equals null, return 2. So we can literally just do if temp right equals null and temp left equals null. Okay, so this is our second base case. So what happens in our second base case? We just return 2 pretty much. So what we're going to need to do is we are going to do answer, because we have to we know we're returning answer at the end. So answer equals answer times 2, right? Because that's going to make it 2. And then what we can do here is we can return, actually, we don't want to return answer here because if we see that it's being multiplied, you know, so it could have more stuff. Well, if temp right is equal to null and temp left is equal to null, that means there's not going to be, there's no more, you know, iterations for it to go. So I think we can actually just return answer right here. So we got this base case. So base case 2 done. If left is null and right is null, we're going to return 2. So we're going to multiply the answer by 2 and then we're going to return it. So now let's go to our third base case, and it says, okay, if root left equals null, return 3 times root right. So foo root right. Okay, so we're going to go just simple if statement. If root left equals null. So what does this mean here? Remember that when you're doing recursion, the order of the base cases matter. So if this base case doesn't get procced, that means the left and right are not null. Both, you know, either one of them is not null or they're both not null. Then we're going to say, okay, if root left is null, so if this is true, if line 10 is true and line 11 is true, that means that our root right is not null. It's according to our base cases, our root right cannot be null if we reach this point and we enter this if statement. So that's why they call foo root right, because they know that root right exists. So what we're going to do is we're going to go, okay. And also we're returning this 3 times whatever answer is. So we're going to do, first let's just do that multiplication. Answer equals answer times 3. And then, okay, now we have to pass root right into our function. So how do we do that? Well, we know that this while loop is what is replacing our recursion. So if we want to, right now, if temp is pointing at root and it's working with the root, and we want it to work with root right, we have to change temp equal to root right, if that makes sense. So we're going to do temp equals, and we're not going to put root, because remember, root right is the same node every time. So we have to put temp right. Temp right. Temp equals temp right. Okay, and now, once we call, let's think about how recursion works. So once we call the next function is going to start and then go through before the first function continues to the next line, if that makes sense. So what we want to do here is we want to go, okay, we need to remember the order matters. We need to start from the very first base case. So we need to restart our while loop from the top. So what I like to do is I use continue. And then we just put continue. And what that does is it's gonna send, or what continue does is it goes back to the very beginning of our loop, regardless of where it's at, and it starts from the top again. So that's gonna do that for us. Cool, so we have that base case done. Ooh, this red is really bothering me. That's okay, that's okay, that's okay. It's just because I don't have my libraries included. So, we got 3 of the base cases done. Let's do the 4th one. So if root right equals null, return 4 times foo root left. So think about it. If none of these base cases are true, that means that root right has to be, has to be null. Because think about it, this first one is checking this, or the second one is checking if both of them are null. And it says, okay, that's not true. And it's checking, okay, is the left one equal to null? And it's gonna say, okay, that's not true. And if that's not true, then the right cannot, if that's not true, then the right has to be null. If that kind of makes sense. The right has to be null, or they're either both not null. If you guys are following there. So that means one of these base cases has to be true. So let's work on this one right here. If root right equals null, that means if root right is null, that means left cannot be null, because one of them has to not be null. If root right equals null, what does it do? It's returning 4 times foo root left. So we have to do our answer equals answer times 4. And then remember, we want to start the function over again with our left. So we're gonna do we do it like this: temp equals temp left. And then we want it to start from the beginning, and so we're going to go continue, and then that's going to bring us back to the top of our beginning. It says like, okay, so we're checking temp right. We're checking if they're both null. They're not. Okay, sweet. So that means one of them is not null. So if left is not null, that means either right it's possible for right to be null. So that's why we do this statement right here. And then we check, and if they're both not null, so if they're both existing, then we do this last one where we compare the two, and then we call one. So let's do that. So if we get all the way down here and none of those if statements happen, that means they're both not null. So then we can do a comparison here and not worry about seg faulting. So what we're going to do is we're going to say, we're going to have to use it. I think we can use it. I think it'd be safer to use an else, but I think we can use an if statement too. So like if temp right data is greater than temp left data. So open this up. If temp right data is greater than temp left data, we're going to return 5 times foo root right. It's like, okay, so we're going to return, well, first we have to manipulate this. Answer equals answer times 5, and then we have to call foo root right. So we have to move temp over to the right. So we'll say temp equals temp right, and then we want it to start back from the beginning. So we're going to go continue. And that's going to send us back to the top here. And then we have one last line. Return 6 times foo root. So if none of the base cases are true, so that means the left and right are both not null, the left is not null, the right is not null, and the right data is smaller than the left data, then we're going to return 6 times foo root left. So what we're going to do here is we're going to go answer equals answer times 6. Then we're going to say temp equals temp left, just to make sure. Temp, yeah, so temp equals temp left. And then you don't have to put a continue here because it's just going to loop back to the top, if that makes sense. And then it's going to check all of these guys, and then it's going to return answer. So do not make any recursive calls in your solution, and do not use any breaks. So a lot of the time we could have put like a break here. That's I think pretty much the only place you could have put a break, and it would have kicked you out, and then you would have returned answer. So let's go over this real quick. What do we have here? So we have an integer. We're rewriting a recursive function, and we know that it returns an int. So first thing we did, declare this int. You know, we set it equal to 1 because our very most basic case is returning 1, and we're using multiplication. And we know that 0 doesn't really work well with multiplication. And then we say, okay, to do recursion, we need a loop that goes forever until a base case is met, and that's what our while loop is for. But also we have to understand that this recursive function is not manipulating the tree in any way. So we need to use a temporary pointer to look at all the nodes of the tree without manipulating them. So that's why we set this temp equal to root, and then we passed it in with our base case here, and then we just pretty much just checked for all the base cases in our recursive function, and we just did the math that was included with them. And then when they asked us to call the next iteration of the function, all we had to do was move temp over to where it wants us to move it over, and then we had to make sure to tell it to go back with continue to go back to the beginning, because we remember order matters with recursion, and we need to check the first base case first every time. And then we just did that with all the if statements, and then at the very end we returned answer, pretty much. So I hope you, because the only thing I'm a little bit worried about is this guy right here. Because let's think about the very, very last iteration. Okay, it passes in a pointer and it says, okay, is the right equal to null? Is the left equal to null? And we'll say yes. Okay, no, that would work, because at the very, very end, both the right and the left are going to be equal to null, and this is going to stop it from calling this an extra time. All right, guys. Thank you so much. You guys have been killing it this semester. I hope this video was helpful. I'm gonna try to go over more foundation exam questions just to help you guys study. Any advice? I think the best way to study for the FE is just by doing old ones. Like, just do the old practice test, because I think literally it's 80% studying the format of the test, and then 20% like studying. Obviously, you have to know the material, and it's good to know the material. But it's once you know the material, and I would really focus on studying the tests themselves. Okay, guys. Thank you.